Okay, I'm Lester Knutsen with Advanced Data Tools, and this is our next webcast in the Informix Best Practice series on running Informix in a virtual machine. And I've done this presentation a couple of times, but I've done a bit of work on it. And one thing you may have noticed is I took the word monster out. Originally, I called this running Informix in a monster virtual machine. And the reason I took the word monster out is not everybody runs it in a big virtual machine, and I want to address little virtual machines too. So just a quick background, I'm Lester Knutsen. I've been working with Informix since 1983 and been doing Informix consulting and training and programming and everything with it. And sort of what we'll talk about is what is a virtual machine. VM is virtual machine, and the problems and benefits of running Informix in a virtual machine. And then I want to share with you some new benchmark and testing. And I have here in the background ESXi running. And you can see from my CPU log, it's a fairly busy system right now. We'll take a look at some benchmarks I'm doing on that later on in the webcast. And then I want to talk about some recommendations and best practices. And if we were doing this live, I'd say, how many of you are using VMs? But I'm going to think probably most of you are. So just so we're all talking about the same thing, a VM is when you have a host machine that runs one or more other guest operating systems in a virtual environment. Typically, this can be done using Linux, it can be done using AIX, it can be done using Solaris, VMware, is one of the more popular ones that I see a lot of people using nowadays, and I'm going to specifically talk about VMware and running Informix in VMware. But it basically allows you to run multiple guest operating systems on a machine. So as an example, I have a machine here called Babe, babe.advanceddatatools.com, and it's running, let me scroll down here, it's running 1, 2, 3, 4, 5, 6 virtual machines, and they're all busy doing a benchmark right now, which is why it's kind of busy. So Babe is one big machine. And whoops, did I just lose the screen? Okay. So this is what I'm going to show you is this one virtual machine, Babe, and we'll look at some benchmarks I have with it in a minute. So the key to a virtual machine is everything is shared. CPUs, disk, memory, network cards are all shared. So if you have a virtual machine like I do, Babe, it has 2 network cards. My 6 VMs are all sharing those 2 network cards. And they've got to play nice with each other. If one VM hogs the network card, it will slow down the other VMs. And so that's sort of the key to virtual machines is all the VMs need to play nice and get along together. Now, the benefits of running VMs is you can partition one machine into multiple machines. Supposedly, you can get more work done that way. You can also isolate hardware problems. It's very nice on my virtual machines. I created one VM image, and then I could copy that VM image to start all the other 6 VMs. They're all copies of that one original VM. And if I needed to, I could move them I have 2 or 3 other machines that run virtual machine on the desktop. I could move any one of these VMs to my desktop. I could move them to another VM server if I had another VM server. So it's very nice to be able to just pick up a machine and move it without having to move hardware. You're moving a virtual image. Just to give you an idea of what you're really moving is if I come here to the storage and look at the storage of this machine, and I do have it's very busy, so it may take a minute to come up here. But in looking at the storage, you'd see that there are directories on the disk there, and all I have to do is copy that directory with all the VM files, and I could move that to a new directory. Let's just browse that one disk. Here, go to the VM directory, and here are all my VM files. All I have to do is copy that directory, and I've got my, I can set up a new virtual machine that way. Or copy that to my desktop, and I've got that same virtual machine on my desktop. So it eliminates hardware dependencies. Now, there are some advantages to disadvantages to that, and I'll talk about that when I get into the benchmarking. Now, with Informix, you can share resources. You can take a very powerful computer and share resources. The other thing I've seen some people do very effectively is when you have peak periods like Christmas shopping, and you can then increase the number of CPUs and the amount of memory if it's within your license for the virtual machine that Informix is running on. So you can take advantage of peaks when you need extra performance, add that to the virtual machine and add more resources to that machine. You can also, since everything's virtualized, if you need to add disk, you don't have to open up the hardware to add disk. If you have a SAN, you can add more disk from your SAN to that virtual machine. Another benefit of virtual machines are snapshots. Think of snapshots as backups, where they capture the state of a machine. You're about to do an upgrade. You want to have not just a backup of Informix, but the whole machine before you do the upgrade. You take a snapshot. If the upgrade doesn't work, you just go back to that previous snapshot. So there are some nice benefits with running in a virtual machine. Now, the cost is what you've got to be aware of. Don't let anybody tell you running in a virtual machine will be faster. From the VMware performance guide, they estimate that a virtual machine will only be 90% as fast as the native hardware. And I'm going to show you some numbers that indicate that's probably optimistic. 80 to 90%, I think, is more real. I've got 2 good white papers here from VMware on virtualizing and the cost of virtualizing. So you don't want to virtualize to make things run fast. Bare metal is always going to be faster. You virtualize because it's easier to manage. And when you do that, you have to, and this is sort of my point of this presentation, you have to take into account some best practices so you get the best performance possible with your virtual machine. Now, the simple way to think about the cost of running Informix in the virtual machine. Informix has a request for some CPU time or for some disk. It sends that request out to the OS. On bare metal hardware, the OS will respond and give that data back to Informix. In a virtual environment, the OS then sends that request out to the virtual machine task manager. And the virtual machine task manager has to stop what it's doing and respond to that test. And so if the virtual machine task manager is busy, you may have a slight delay here on the response to the virtual machine. So every CPU, memory, I/O request is going to go through an extra layer when you run in a virtual environment. That's the cost of the easier to manage, which is the benefit of running in a virtual machine. Now, the problems are the overhead cost of memory and CPU, and I'll give you some numbers when I show you my benchmarks. Basically, at least 90%, 10% of your costs are going to be taken up by the VM. The other thing I've seen is people will start out with, we'll put Informix on a VM here, and it runs great. And then the VM administrator, who's not the Informix DBA, comes along and says, that machine looks idle. I'll put 3 or 4 more VMs on it. And suddenly the Informix performance is terrible. I've done several performance tune-ups with Informix where the problem hasn't been the Informix instance at all. It's been what else is running on that virtual machine and the performance impact that is having on the machine. A second thing is it's very hard to benchmark Informix. And I will show you this as an example. I ran the same benchmark over and over again 50 times, and I got a 20% variance in the performance. I'll show you that in just a minute. The last problem I want to point out is snapshot corruption. Because Informix does a lot in memory, if you take a snapshot, you're not going to get what's in memory. You'll get what's on disk. And when you try and restore that snapshot, you may get a corrupt system because of that. So I'll point out how to do a snapshot at the end of this presentation. It is possible to get good snapshots. There's a little trick to it. So these are some of the problems of running Informix in a virtual machine. Now, there's an interesting discussion, and it's worth Googling, monster database VMs at the VMware conference about people running these big VMs and the limits for memory and disk space that VMs have has just gone through the roof, so you can do this. Typically, a monster VM is when the VM takes more than 8 CPUs and more than 256 gigs of RAM. And it's well worth reviewing. Some people are running Oracle and SQL Server. A lot are running SQL Server, big SQL Server VMs, and it's interesting to look at what they do. And a lot of what they do on the VM side, I've taken and used in Informix. So I'll go to a VM session on running Oracle in a VM just to learn how they tune the VM, and then take that back and you can do the exact same things in Informix. A monster database is a monster database, whether it's Oracle or Informix or SQL Server. And how you tune a VM for each one of those is pretty much the same. So a couple of terms we need to understand. A socket is a computer chip, and each computer chip can have many cores. Babe, which is the machine I'm using here, has 2 sockets, and each socket has 6 cores. And then the newer Intel chips are all hyper-threaded, which means each core can run more than 1 thread. And Babe, which the machine I'm using here, is running 2 threads per core. So to the operating system, it looks like it's a 12-core machine. But in reality, it looks like it's a 24-core machine. In reality, it's only 12 cores. 2 sockets, 6 cores per CPU, each running 2 threads. And then IBM has a whole processor unit, which I'm not going to get into here. So here's sort of an example. You have 2 sockets, 2 chips. In this example, each chip has 5 cores, and each core has 2 threads. So it looks like it's running 20 virtual cores. But in reality, these virtual cores, only one thing can run at a time on a chip. And so in reality, it can only run one thing at a time. Now, the way virtual cores work is something runs and then it has to wait. And while it's waiting, it runs the other thread. And it goes back and forth between the 2 threads like that. One of the monster VM talks I overheard, the guy described it as you really don't get things twice as fast with hyper-threading. It's about 1.2 to 1.5 times as fast by turning on hyper-threading. And in many cases, turning on hyper-threading doesn't really gain you that much. Now, another important thing with virtual machines and newer VMs is NUMA. Particularly if you're running VMware 6 and 6.5, which I'm using here, they've actually improved it quite a bit. It assumes NUMA by default. But NUMA is where is the memory compared to the chip. And here's an example. I have 4 chips here. Each chip has 6 cores. And they're banks of memory, and the memory is going to be tied, this is just the way chip architecture works, to a chip. So if you're here on the top left core and you need some memory, this memory right here is going to be the fastest to access. If you need to get some memory from way over here down the right, that's going to be a little bit slower. And so what you want is your application using this first core in the top left to always get memory from the top left. Here's an example of it, this big circle here on the left. What you don't want is down here in the bottom right. If it has to go over here to get memory, that's a bit further away. And having NUMA set right so that your applications run on the cores that are closest to the memory they're using is kind of important. ESX does it by default now very well. Now, benchmarks. So let me give you some numbers. And I'm going to just show you the spreadsheet I did. When I turned on Babe the other day, I started from scratch. I created 1 VM. And on that 1 VM, I ran a benchmark. And this first column B is the sequential list of times. Column E is the same times except sorted from fastest to slowest. And this is a benchmark that runs in about 12 to 13 minutes on a bare metal system without a VM. So you can already see there's a little bit of overhead in running the VM. Now the fastest I got it was run number 4. It ran in about 15 minutes. The slowest, and I just ran this 54 times. I was going to run it 100 and I just stopped at 54. The slowest was 19 minutes. The exact same thing, just running in a loop. Nothing else running, no other VMs. I didn't have any other VMs created. So from 15 to 19 minutes, that means there's about a 21% variance in performance in running in a VM. And that's something that you and I don't have control over. Years ago, I tried to do the fastest EVA contest in the VM. And this was exactly why I didn't do it, because you couldn't tell if someone's run was really faster or not, or it just happened to be the variance of the time they got. So this is with one VM, nothing else running. I'm seeing a 21% variance on time. Now, taking the same VMs and running all 6 at the same time, and this is not running that whole job. This is only running a DB import. I'm running on 6 different VMs. And to give you an idea of how they're configured, VM 201 has separate resources. It has its own CPU, its own memory. It's not sharing them. VM 202, 203, 212, and 213 are all sharing resources. So these VMs here are all sharing resources. They're competing with each other for CPU and memory and disk. And then I have one separate VM here that is huge. I gave it extra resources and extra memory and extra CPU. These other VMs all have 16 gigs of memory. This last one has 64 gigs of memory. The first 6 VMs all have 4 CPUs. That's virtual CPUs. This last one has 12 virtual CPUs. And look at the time difference. They're all doing the exact same DB import. 15 minutes to 50 minutes is the time difference. So that's the kind of variance you will get in VMs. So don't do VMs for performance. If you need performance, bare metal is going to be your best bet. You do VMs for the management and the scalability of it all. Now, did I just lose my WebEx? Okay, Tom says it's still up, so let me keep going then. So that's just one simple benchmark. Now, I worked with a client last year. This was a lot of fun. They wanted to do a very large database. And so we used our benchmark SQL tool, simulating 1,000 users on their system. They also had some data warehouse ETL scripts that they ran, and what I'm not going to tell you the numbers, but I'm going to tell you what we did to get the best results. And this is on VMware version 6, ESX 6. So it's an earlier version. It's last year's version, but these things still apply. The first thing is they had 96 CPUs on that box. And we found that the best performance was with only allocating 92 to the VM. So they had one box, one VM. This is kind of cool. One big box, and they only ran one VM on it. And their goal was to max out that VM to get the best performance on it. If they had 128 CPUs, they would have wanted to run all of them. Well, what we found was you needed to save 4 CPUs for the VM overhead. So that's the first takeaway from this. We got the best performance with 92 virtual CPUs, saving 4 virtual CPUs for the overhead. You want to disable hot memory CPU swapping. This tells the VM, particularly if you have multiple VMs on this box. I don't think it really made a big difference here because we only had one VM. But this keeps the VM from moving memory around and keeps it very, very fixed for you. So on your production systems, you want to go in and do this. Hyperthreading. They wanted to turn on hyperthreading. We actually did some tests with hyperthreading off and on. And in both tests, we ran the same number of on inits. So they had 92 virtual CPUs. We ran, I think, 88 on inits. With hyperthreading off, they only had half of 92 of virtual CPUs. And I think we got as good, if not better, performance with 88 on inits. I have a question mark here because they really wanted to turn on hyperthreading. And it was almost like we didn't do enough testing with it off to really say that it performed better. When you talk to the Oracle and SQL Server monster DBA guys doing benchmarks, a lot of them say turn off hyperthreading because you will get better performance. And I think with Informix, the Informix on inits do hyperthreading internally. And so by turning off hyperthreading at the CPU level, you give a bit more resources to the Informix on inits to do their own internal threading. Memory. They had 512 gigs on the box. We found we could only use 490. We played with that a little bit, but 490 was the max amount of memory. Needed to save some memory for the VM for things to work well. And then NUMA. In ESX6, you have an advanced memory option. This is where you can turn on NUMA. And you basically say use memory from the nodes and check off the nodes. So they had 4 sockets, and this is saying try and align the work with the sockets and the memory that it's closest to. In VMX 6.5, it does this automatically, which is very nice. So, what are some recommendations in going through this? Before I jump into that, let's go back and look at the VM. I got logged out here. Let's see if my storage came back. It didn't. Oh, yeah, there it is. So I've got 6 disks. A good practice, I think, is I have 6 disks on this system, and I could have created one big disk. Instead of doing that, I created a 6 disk matching my logical volumes, match my disk. I didn't have to do that. I could have created one big data store. But this way, I know what's on each disk, and I can match the performance of that disk to what's going on. And let's see if it's still busy. Yep, it's still kind of busy. You can see I've got spikes here where my CPUs are hitting 100%. I'm just running the same benchmark over and over again on 6 VMs. If I come here and look at the VMs, and let's just open this up if it will let me. I am taxing that machine, so that's why things are a little bit slow. Um, you can see here, this is an interesting thing. So train one, I told you, had its own resources. They're not shared. Look at how much CPU power it's getting. Train two is sharing resources, so it's only getting some CPU. Train three is sharing resources. It's getting a bit more now. Train 13 and 12 are sharing resources. They're getting very little CPU. These are the two slowest ones on this box. And this is one of the problems with VMs, is you have no way of knowing when you create a VM that's on a shared system what percent of the resources it's going to get. The VM decides that. Unless you go in and specifically say, I want this VM to have X percent of the resources, it could potentially get less resources than it has. I was going to, let me go back in here. I was just going to take a look at one of these VMs. And you can sort of see the resources for that VM by itself. It's kind of busy. The memory's been pretty stable. This is my big VM, and this benchmark is barely taxing it. It's only using about 20% of the CPU. But if I come back here and take a look at 13, same benchmark. I've got a system here. Now, this is where I think these numbers can prove misleading. To the VM administrator, they'll say, oh, 13's not very busy. But it's actually one of the slower VMs here. The VM is giving it less CPU power, so it's showing up with the CPU being less busy. And the point I want to make here in this little thing is, to the VM administrator, it looks like it's not busy. To you, the DBA who's timing things, and this is why you need to time things, that's the only way you can go to the VM administrator and say, why is this taking longer than this? Why is it taking longer in a VM than in bare metal or in a standard VM? So that's sort of the key to VMs. So the best practice is you got to have a service level agreement for your VMs. You've got to go in and say, this is the kind of performance I need. And you need to baseline and measure your performance so you can say that. I've worked with a number of different ways of doing this. One is to take a batch job and say, how long does it take to run? And it needs to run that long in the virtual environment. Another way is to take something like the number of users. We need 16,000 users, and we need to be able to have them get a simple query done in so many seconds. And most web front ends can measure milliseconds of response time. And I worked with one organization that I really liked, and they knew all the time from their web front end to their VM what the response time was going to be. And they monitored that and kept track of it, and that was their baseline. The other thing is you want to separate production from QA testing and development. And this is really key. You've got, I think, two types of VMs. You've got production VMs, and then you've got non-production VMs. And in the next couple of slides, I'm going to talk about recommendations for each kind separately, because they're very different. For non-production VMs, these are VMs for development, QA, testing, where performance is not important. You can do something called thin provisioning of disk. And this is you don't allocate the disk space on the VM until the OS really needs it. So you can create a VM of 250 gigs, but then when you go out and look, you're only using about 100 gigs because that's all you really need. Now, the downside of that is when you need more disk, the OS has to go out to the VM and the VM has to go allocate it. And one, that disk space is going to be fragmented now. And two, it does take some time, seconds, but it does take time to allocate it. So non-production systems, that's okay. The same thing with CPU. You can affinitize CPUs in your VMs. For non-production, non-critical VMs, don't affinitize. Let the VM manage them. That way, you can have 6 VMs that maybe need 30 CPUs total, and they can run on a 24 CPU system because none of the CPUs are affinitized. If you start affinitizing CPUs, then you're saying VM tie this VM to this CPU and don't share it. That you want to save for your production ones. So this is key for non-critical, non-production. I actually think you ought to keep them on a separate box from your production VMs. Now, this is the key one. For your production VMs, the first thing you want to do is make sure the disk space is allocated when the VM is created. That's called thick provisioning. That means if you need 250 gigs, make sure the VM allocates 250 gigs when you create the VM. That way the space is there, you know it's there. Now you can always add space later on if you need to. That's fairly easy to in a VM environment. But the space is allocated and reserved for your production system. The second thing is you want to tie your CPUs to physical cores. And you want to allocate CPUs to cores. And then if NUMA is really required for your production systems, you want to turn that on and use it. Now, if you can, you also want to set up direct disk access. If you're not using the VM, but you have your own SAN or something like that, you want to have direct disk access. You want to think about enabling or disabling hyperthreading. I haven't done enough benchmarking to be definite on this, but it's really interesting. The monster database talks on SQL Server and Oracle, they seem to indicate disabling it is perhaps better. Everybody seems to agree enabling NUMA and memory affinity is better for your production systems. And you want to disable the hot swap of CPU and RAM. You don't want, a VM, you don't want the RAM and the CPUs you're using to be moving around on your big VM box. You want them allocated to one set of places. This is really key. Do not overschedule or oversubscribe production systems. Oversubscribe is when you have a need for 30 CPUs and your box only has 24. You can run it. That's called oversubscribing. And I see it a lot of times where people have 8 or 10 VMs running on the same machine. And one VM might be a critical production one, but they have the CPU set to swap. And then they have all these other VMs. And maybe somebody's doing a test, like me, doing a benchmark on one of the development VMs. and that can take away resources from a production VM. So on a production environment, never overschedule, never put in more CPU, virtual CPUs than you have physical CPUs. And the same thing with disk. Don't oversubscribe resources and disk on your production systems. So on a production system, you're really only going to get 90% of the hardware because 10% of that hardware is going to go to the VM. But that makes it so much easier to manage. And the real benefit of VMs is a little bit easier to manage compared to bare metal. Now, I told you I'd talk about snapshots. Let me open up a window here. Informix, I'm on train 3. On mode -C block. That does a checkpoint and blocks writes until I do an unblock. This is the time you want to do your snapshot. So you do an on mode -C block, make your snapshot, and then an on mode -C unblock when you're done. That way you'll get a good snapshot that you can use. If you don't do that, what's interesting is it works 90% of the time, and it seems to be that 1 or 2 or 3% of the time when it doesn't work is when you really need it. So that's why I always recommend, if you're going to use snapshots, and that snapshots are one of the great features of VMs. The fact that before an upgrade or an OS change or a patch, you can do a snapshot, and if things go wrong, come back to the way it was before the snap. It's like, taking the hardware back into a time machine. I think it's kind of cool the way this works. The other real advantage to VMs is you can move copy VMs back and forth. Where is my interface here? One of the things I like is I can come over here and register a new VM. And one of the ideas is to register an existing VM, which could be a copy of another VM I made. And so I can take train 1, make a copy of it, and then register it as a new VM. And I'm up and running, and I have another VM. That's basically what I did with all of these. I took train 1, it's the exact same configuration. After I copied it, I went in and changed some settings, but it makes it very easy to take your production environment and make a copy for QA testing. You can get exactly what production is like for QA testing that way. Okay, so that's sort of a summary of best practices for using Informix and VM. In summary, it does work. Don't do it for performance. Do it for management. It's easier to manage that way. Don't let anybody tell you that it's going to perform better. But what you need to do is differentiate between production systems that have a service level agreement where you have benchmarks and times and can say, hey, it needs to perform this fast, from non-production systems where you can put a bunch of developers and try different things out there. Now, I'm going to take questions, and to do questions, what you want to do is find the chat button, and let me do this so I can see the chat button. So find the chat button and ask your question in the chat window. And any comments on Docker? That's a good question. And I'm not a Docker, I haven't got that much experience with Docker. I was going to say, Tom, you're on. That might be a good question for you. Tom Beatty works with me here. Uh, Let me unmute Tom, see if if Tom's there. Uh, and Tom, you want to say anything about?
Am I coming through, Lester?
Yeah, you're coming through now.
All right, so I'm not a Docker expert by any stretch, but it can be really useful, and they actually do have an official release now on Docker for free for use with the Innovator C edition. But if you build a Docker image and then you set it up to deploy, it makes it really easy to build and tear down and throw up new development and test boxes, because all you have to do is just take your virtual system, spin up a new Linux install, have the Docker set up the system however you need it to, and your developer is off and running with very little work. I can't say I'm a big expert on it, but I have done a little bit with Docker. I've also used some of the other tools like Juju with on the Ubuntu set for the same concept, and it makes it really easy to spin up test systems. One other thing, while I've got the mic, just in case there's any question, refer to the system. It's an old server of ours called Babe. It's an inside or not so much an inside joke, but a joke we have in-house because it was our big blue system from IBM. And it's the Paul Bunyan tale. So just in case anyone was wondering about the naming, that is why.
Yeah, I've always thought it's named after Paul Bunyan, not
well, the ox.
Yeah, the ox, not anything else.
Yes.
Thank you, Tom.
Mm-hmm.
Another question that came through, I've got a whole bunch of questions here. Huge pages. I'm a big fan of huge pages, especially on your production system. And yes, I would turn that on. It's turned on all these systems. It's part of my default training install that I do is turn on huge pages. So all these systems that I'm running here are running huge pages. Another question is, how about running diskless in-memory databases in a VM? I love SSD drives. I actually, there's a really good article I read someplace not too long ago, basically saying hard disk industry is dead and SSDs are going to rule. One of the things I've been trying to upgrade Babe, I wanted to get 8 SSDs added to it. Most of my desktops now all run Informix on SSDs. All my development is done on SSDs. So that's one part of your question, and that is SSDs are really good. One thing to note about SSDs is a lot of the old planning. In fact, we should do a separate WebEx on disk drives. But a lot of the old planning on SSDs, particularly on fragmentation, are not as important because SSDs handle fragmented data really well. In fact, it doesn't matter to an SSD. It can get data anywhere on the SSD just as fast as from any other place. And it's not like a spinning disk where that is important. So I'm a big advocate of running production SSDs, production databases on SSDs. I just put in a multi-terabyte data warehouse that was on SSDs for a client. That was really good. Now, the second part of that question was running in-memory databases. And this is, you can actually do this. You can, one of the reasons we got Babe with so much memory was to run the Informix Warehouse Accelerator. And it's been our benchmark machine for testing the Warehouse Accelerator. It has 128 gigs of RAM. And with that and the Warehouse Accelerator compression, we could put a 200-300 gig database in memory. And I haven't, since I put ESX on, I haven't reconfigured that. That's one of the things I'm going to be doing in the next week is putting the warehouse accelerator back on. I'm expecting really good performance. But again, when I do that, I'm going to dedicate the whole machine to one VM. And it will be really interesting because we do have numbers and we'll benchmark that compared to where how it worked with the whole machine bare metal. Now, there are a whole bunch of questions. Let me go back here through the list. Yeah, IBM has published developer and C innovation images on Docker. For a snapshot, can I use on mode to go to single user mode? Yes and no. In single user mode, data can still be in memory and not written to disk. And so for a snapshot, you really want Informix to write everything out to disk and then not write anything, not be updating anything while you're taking the snapshot. So on mode -J, you could have people doing the user Informix doing updates, and so that could be not as successful. On mode where you're in quiescent mode, where no one can access, run DB access, then yes, take a snapshot then. Because if you're running, that could be changing your disk structures and that could make changes in memory. So let me, boy, questions are coming through fast and furious here. The benchmark, yes, I did run it on bare metal, and that was a really good question. Time on that was, it was about 10 to 12 minutes. The difference is on bare metal, running it over and over again on one machine, and I've run it on multiple machines. This is sort of what we have done in the past for the fastest DBA contest setup. And typically I would get a new machine. I would run the same benchmark over and over again. I would get maybe a 1% variance on time, maybe 1.5% variance, not 20%. And I think that's the big difference is on VMs you see such a big variance and difference. Yep, SSD drives, there's a little bit of, okay, network setup. This is a good question. And this is where I think it's really important to have multiple network cards in your VMs. Because in my case, I've got 6 VMs. They're sharing 2 network cards. If I was doing backups at the same time, I would saturate those NICs if I was doing on-bar backups over the network. You really need to think, just like with memory and CPU, on your production VMs, having a separate network card just for that VM. And if in a bare metal situation, I have a lot of clients that would have, 4 network cards on a production system in bare metal. You want 4 network cards for your VM. So the answer is yes. Separate network cards are going to be better. Now, SSDs with fragmentation. That's a really good question. Is PDQ still valuable? Yes. And the key here with PDQ, for it to really work, you need multiple SSDs. So what you want is, and one of the fastest arrays I've worked with is 6 SSDs, a little homegrown array I built at home. And I spread the data out over those 6 SSDs. And with PDQ, reading from those 6, that's the fastest reading I've ever got, was reading from all 6 SSDs at the same time, blazingly fast. So PDQ, as long as you have your SSDs separated and you have a big enough controller for those SSDs. Where it starts getting interesting is in controllers. If you have all your SSDs going through one controller, the controller can become the bottleneck. Still, more disk are always better. SolidDB, is that a product? I have not used SolidDB, and I'm not familiar. That's a good question for IBM, and I'll save you that. I'd go ask your IBM sales rep on that. Licensing. Licensing is affected by virtual machines, and I've tried to avoid talking about it. I always hate talking about licensing because one, it's very complicated. IBM tends to want you to pay for the PVU cost of the host machine, not your VM. If you're going to run it in a VM, they want you to run their license manager on the VM, and that license manager is like running DB2. So I tend to think licensing is very affected by virtual machines. And this is where I think IBM is behind the ball. Apparently, from what I'm listening to, talking to SQL Server and Oracle folks, their licensing costs can go down in virtual machine environments. I'm not seeing that same thing in Informix. And so that's my quick take on that question. We've got time for one last question here. And if anybody's thinking of the last question, I'm just going to finish a couple slides I want to tell you about. So we have 3 more Informix Best Practice webcast coming up. The next one is really the September one, but I'm doing it October 5th because my schedule's crazy in September. I'm going to walk through how I use the scripts that I've developed from the SysMaster database to do an Informix health check. And I'll describe the scripts I use and what the output looks like and what I do with it. So it's a different twist on my SysMaster presentation. Then in October, the real October webcast is going to be Mike Walker talking about Informix performance tuning basics. He did a presentation at the IIEG conference this year on this, and after and that went way over time. And after hearing that, I was like, you got to do a webcast on that. So we'll do that in October, and then in November. We're going to have Art Cagle back again to do one on schema design and what are the best practices for building your schema in Informix. And then in December, we'll do another one. It's the topic we're still batting around, but it'll probably be, well, I'll just say it's a mystery topic right now. Informix Training is really interesting. Our performance tuning class that we had in September got booked, and I've had 3 requests for another one. I'm thinking of doing one in January, but you know, if you wait, and this is what everybody did, was they waited too long to sign up for this class. If you wait, you'll miss it. If you're interested in the performance tuning class, drop me an email. And January or February, we will probably do one. We do have an Informix for Database Administrators class. I think we've got 1 space left in that class coming up in September 18th. This is for new Informix DBAs. It's been a lot of fun. I've done this class several times this year. And most of the time it's been for Oracle DBAs who are being told to learn Informix. Always a fun class to do that way. And just a note, we're Advanced Data Tools. the key thing we do is all we do is Informix. We do remote DBA support. We do 24/7 monitoring and support of a bunch of servers around the country. We do performance tuning. We do training. We do consulting. That's pretty much all we do. And so let me take a last look, see if there are any last questions. Important parameters we should monitor or look at from the host when we have a performance issue. First thing, that's a really good question, Robbie. I really like that. First thing is to find out what other VMs are on the same host. I've started out now saying, okay, show me this picture. You know, I want to, whoops, see if I can log in real quick. Show me this picture so I can see what other VMs are running. That's the first question. And then take a look at the CPU usage by these other VMs. You know, and your VM administrator, what I've found is they'll come and say, oh, look, your VM's hardly using any resources here. Well, from the Unix side, if I was to run SAR or top, I'd be seeing I'm using 100% of the CPU. And that's typically, I think this little chart here on the VM side is sort of a lie. It's showing you from the VM side what it's allocated to you, not how much from the guest operating system you're seeing used. So that's the first thing I would do. I would go run SAR or top on the VM and say, why am I using 100% of the CPU here when this is only showing 20, 30, or 40% of the CPU? So there's a lot I could talk about that. There's another really good question here on integrating Informix with other monitoring tools like Nagios, Check, MK, and SolarWinds. That'd be a fun topic too. We ought to think about that for a future presentation. Anyway, I am out of time, you guys. This has been a great webcast. You guys have been a great audience. I really appreciate it and appreciate you taking the time to attend. If you have any follow-up questions, please drop me an email. Like I said, and September is really busy for me. I tend to travel and do consulting gigs. So if I don't respond right away, I apologize. But I will respond, you know, usually in a couple of days, if not right away. It's fun. Sometimes I get somebody that sends me an email and I'm able to respond right away, and I always like that. So thank you all for attending, and have a good rest of the day, and we'll see you on the next webcast. Bye now.